All right, welcome back, everybody. Here we go. This is section 2.2. The number of inmates incarcerated in the United States prisons is shown in the table off to the right. Okay, and no surprise, the our x values are going to be on the left side of the table, the year, and the y values will be on the right side. Number of prisoners. Notice the it's in thousands, and so well, the number 1,000. Well, so basically, you would take, if you want to know the actual number, you would multiply each of these numbers by 1,000. So the first one, if you wanted to know, it would be 1,448,000 approximately. Okay, you're not you're gonna have to worry about that too much in this problem, but I did want to point that out. Okay, so they say consider the year 2000 to be year zero. All right. So this is going to be year 5, year 6, 7, and so on. Okay, and that's what we're going to use. It just sometimes when you go to your calculator and you use the full year, it's just the numbers are too big for the calculations. Oh, that reminds me, I was going to show you something super cool. I'll just do it now. I got to turn. How do I turn that? Okay. So if I go here and I say, oh, no, I want to go to it was yeah, Pearson correlation coefficient formula. Okay. This is one of the formulas that your calculator is doing for you when you do the regression on the calculator. So if for some reason you were thinking, oh my gosh, there's a lot of steps in this, believe me, it could be so much worse. This formula is not as bad as it looks, but it is time consuming, especially if you've got a lot of data. And this is just one of the formulas that it's doing for you when you do regression. So yeah, just count your blessings. It's so much easier using the calculator. All right. So use regression to find a quadratic equation to model the data. Now, I think we can see that they've already found the graph of that equation they're looking for us to find. Okay, so there it is, whatever. All right, and so we're going to do this like we did before for linear regression, except we're just going to pick a different option on the calculator for quadratic. So let's see, I need to move this thing to about there. And where's the clear button? Okay, so I'll go back to stat, enter. And again, if you've got old data, we're going to go up to the name of the list and hit clear, enter. And clear, enter. Now, because there's usually somebody that does this, if you hit delete, notice L1 is totally gone now. And if I hit the left arrow, I don't get to L1. It's gone. Wiped clean by the wrath of God. Okay, so with my cursor on L2, I would go on the next list, I would go second, insert, and I want to insert a new list. I'm going to call it L1, so I'll go second 1, enter, and now it's back. And if there had been any data in there, and I deleted it, and then I brought it back in, the data will still be there. Okay. All right, so let's put this stuff in. Okay, so our X values are year 5, year 6, 7, 10, 11. Okay, and then the Y values. 1493. Oh, that's the year after Columbus sailed the ocean blue. Okay, 15, 20. And again, on these, whenever you're typing the data into your calculator, which happens a lot in this course, you want to double check you typed it correctly. Okay. If anything is off at all, it's going to throw off your equation. Maybe just a little, maybe a lot, depends on the error. I mean, if you accidentally, instead of do 1448, you accidentally do 49, yeah, that'll throw it off by not by much. But if instead of 1448, you do 2448. Well, now instead of that number being off by one prisoner, it's going to be off by 1,000 prisoners, and therefore that's going to be it's going to make more of a difference. Okay, so everything looks okay, and notice that the number of prisoners it's getting bigger, 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 and then it starts going down toward the end. Okay. So it's like, oh, hey, this is probably a good candidate for a quadratic equation. Okay, when things go up and then come back down, or when things go down and then come back up. All righty, so we've got all that fun stuff, and let's turn that thing off and make it big. Okay. You know what? Why don't we just clear that stuff? Okay, so let's take a look at what this looks like on the graph. I know they already gave us the graph, but I'm going to show you how to do that. If I just go to graph, it's not going to show it because I haven't told it to graph those points. So here's what you do. You go to y equals. You make sure plot one is turned on. Mine already is. So yours probably looks like that. If it looks like that, you go up to it with the arrow key, hit enter, turn it on, and then you can always turn it off with the enter key. It's like a toggle switch, like a light switch. Okay, so it should look like that. So mine was, and so by highlighting plot one, that tells the calculator, hey, when I go to my graph, I want to see these points that I just put in, the L1 and L2. Well, mine didn't show up when I hit graph. Well, that's because they're off camera. I've got to aim the camera differently. So I'm going to go zoom 9. Option 9 will show them. And you'll notice those points look, about like what we've got over here. Okay. And just looking at it, you can say, yeah, that looks like a quadratic pattern. It's going up and then it's coming back down. Cool. So now that's not what they asked for. They said, go get the equation. All right, we'll do that. So we'll go stat, right? And instead of option 4, we don't want the straight line that best matches the data. We want the parabola or quadratic function that best matches the data. So I'll pick option 5, and it should say L1 and L2. If it doesn't, fix that. Just like I explained in the chat. I think it was like the section 1.3 video. And you just go down to calculate, just like you did in chapter 1. Now, on this one, it's a little different because, well, we're getting a quadratic equation. In chapter 1, they had the first line was y equals ax plus b. And then they would tell us what a and b are. But that first line, that told us the template for that type of equation, for a linear equation. Well, that's what they're doing here. This is the template for a quadratic equation. So it's going to be y, and then the equal sign, and then the a. And I don't remember if they told us how to round this off. Let's see. 2 decimal places. Okay, yeah. All right, so 2 decimal places, that'll be negative 5.44 for A. Then it says do x squared. Then it says go do a plus sign. Then it says do B, which is this. So that's, again, we're going 2 decimal places. So this 7 is going to increase the 9 to a 10, which is going to make that a 3. And so we're going to get plus 95.30. Then we'll do our X. Then we'll do our plus sign. Then we'll do our C, which is 1,112. And that will be the equation. Okay. So then it says, use your equation to predict the number of prisoners in the year 2020. Okay, 2020, that is going to be year number 20. And our graph on the years doesn't go up to year 20. Okay, it doesn't. It only goes up to year 7. So, oh well. But you know what? Well, we could kind of explore that on our calculator. We don't have to, we might as well. I'm going to go to window and I'm going to push this thing out to year number 20 because the X's are our years. And so, what does it look like? Well, if I were to graph the parabola that goes through it all, It's going to go down, down, down. And by the time it gets over here to year 20, it's going to be way down there. And I don't know, might even be negative, which doesn't make sense. But let's figure it out. Okay. Um, so we'll go to y equal, oh, no, we'll go to second quit to the main screen. All right, so let's see what we got here. So we'll take our formula, and they gave us year number 20. That's a year, that's an x value. So we're going to plug it in for x. Okay, so year number 20, and there's that. Okay, plus 95.30 times year number 20 plus 1112. Okay, so that tells us, so 842 is our answer for year number 20. Does that seem reasonable? Well, based on what we're given, yeah, it does, because like we saw a moment ago, by the time we get to year 20, we've been going downhill for a while. So it should be quite a bit smaller than these numbers here, and it is. Okay. And let's see, I already forgot the number, 842. So 842. So what does that mean? That means 842,000 prisoners in the year 2020. Now, 2020 has already come and gone, so we could look that up and see how accurate that is. My guess is it's not going to be terribly accurate, because our model, now this is important, our model says, goes up and then it comes down, and then it just keeps going down forever. And eventually it's going to be below the x-axis. It's going to start giving us negative answers for prisoners. Well, that's not likely to ever happen. In fact, I don't even know how you'd have negative numbers of prisoners. So this model works great for this data here. Okay. But once you go beyond that, very far beyond that data, like probably the year 2015 is probably about as far as you can go, I would guess. Then this model here is going to break down. This equation is going to break down, and it's no longer going to be accurate. Okay. So that's why when people, sometimes they'll say, hey, we've got this cool model that represents the situation. So in the year 2075, this is what's going to happen. It's like, oh, your model might not work anymore at that point. I mean, it might. It depends on the situation, but often your equation's only going to work, pretty close to the data that was collected. Okay, so using this to make predictions about the year 2030 is not likely at all to be helpful. Okay, in fact, if we went back there and we said, yeah, what's going on in the year 2030? Based on this, hey, we're down to negative 925,000 prisoners. So by the year 2030, this model is definitely no longer useful. But that's how this stuff works.